Welcome everyone in lecture number 2 of Laplace transform. In my last lecture, I have introduced about Laplace transform and how to find Laplace transform of some elementary functions. In this video lecture, we try to learn the Laplace transform of some more elementary functions and their combinations also. The very first example is cos hyperbolic AT. You must know about cos hyperbolic AT. Cos hyperbolic AT is a trigonometric function, is a hyperbolic function which is equivalent to e raised to the power AT plus e raised to the power minus AT divided by 2. Okay, this is equal to cos hyperbolic AT. तो हम इसका लाप्लास ट्रांसफॉर्म सीखेंगे, हम कैसे निकालेंगे. So first of all, recall that Laplace transform of any function of t is equal to integration 0 to infinity e raised to the power minus pt ft dt, right? So Laplace transform of cos hyperbolic at is equal to e raised to the power minus pt, and in place of ft, we replace this function by cos hyperbolic at, which is given to us, okay? So and since we know that cos hyperbolic at is equal to e raised to power minus plus at plus e raised to power minus at divided by 2, so we replace this cos hyperbolic at by this function. Now we take this exponential function inside the bracket, we multiply this with these two, so that we get e raised to power minus pt e raised to power at, okay, and plus second integration is e raised to power minus pt into e raised to power minus at. Now, since this is nothing but Laplace transform of e raised to the power at, as you know, this is the definition of e raised to power at. These both expressions are equivalent. So we can replace this by Laplace transform of e raised to the power at. And this is nothing but Laplace transform of e raised to the power minus at. I have told you how to find the Laplace transform of exponential function in my last lecture. And it is equal to, that is Laplace transform of e raised to power at is 1 upon p minus a, and Laplace transform e raised to power minus at is 1 upon p plus a. Solving these two will get p upon p square minus a square. So Laplace transform of cos hyperbolic at is p upon p square minus a square, while Laplace transform of cos at is p upon p square plus a square. It is discussed in my lecture number 1 of Laplace transform. Next one is, it is discussed in this lecture itself. Laplace transform of cos at, that I have told you. Laplace transform of cos at is integration e raised to power minus pt cos at dt. To solve this integration, we use the formula which is a standard formula of integral 0 to infinity, integral indefinite integral of e raised to power ax cos bx. This is defined here, as you can see. E raised to power minus ax cos bx is equal to this. So we replace a by p, yes, and we replace b by a in this expression, so that we get this integration is equal to this. Okay, you can check e raised to power ax, so this will be e raised to power minus pt, because integration here is with respect to t and here is with respect to x, and here a will be replaced by p and b will be replaced by a. Okay, so when you apply the limit at upper limit, this expression will be 0, because e raised to power minus infinity is always 0, and at lower limit this will be 1, and this is 1 upon p square plus a square, because when you replace, when you put, 0 at place of t, cos 0 is 1. So we have minus p, and because of lower limit we have negative sign also. So this is plus p and this is 0. So we have p upon p square plus a square. So you can memorize these formulas to use them further in more advanced questions. Similarly, we can find the Laplace transform of sine 80, which is equal to a upon p square plus a square. Now you can see here this function is a combination of two exponential functions. One is 3 e raised power 2t and the other one is 4 e raised power minus 3t. So we use the formula, standard formula of Laplace transform of e raised power 80 is 1 upon p minus a. So replace this Laplace transform e raised power 2t by 1 upon p minus 2 as well, and e raised power minus 3t by 1 upon p plus 3. Solving these two, will have 3 upon p minus 2 plus 4 upon p plus 3. Next one is Laplace transform of t square plus 1 whole square. You can open this and separate each and every function, and then use the standard formula of Laplace transform of t raised to the power n, which is gamma n plus 1 upon p n plus 1. So it is gamma 5 and p5. It is 1 upon p and is gamma 3 divided by p cube. Gamma 5 is equal to 4 factorial. Gamma n plus 1. This is a standard formula. Whenever n is a positive integer, gamma n plus 1 is equal to n factorial. So this is 4 plus 1. This is equal to 4 factorial. And gamma 3 is 2 factorial. Next one is Laplace transform of sine 5t plus cos 3t. We can use direct formulas here. 5 upon p square plus 25 and p upon p square plus 9. These are the combination of two hyperbolic functions. One is cos hyperbolic 5t, another one is sine hyperbolic 5t. And again, we use the standard formulas here. Solving this, we'll have 3p minus 20 over p square minus 25. The next one is Laplace transform of sine 2t cos 3t. This is also the product of two functions. You have to separate these two functions by the formula of 2 sine a cos b. So we separate these two functions by this formula. Separating these two functions, we have one function is sine 5t, another function is sine t. You can take the constant term outside by the linearity property of Laplace transform. This is a linearity property. Laplace transform of c1 f1t plus c2 f2t means if a constant is multiplied by some function, you can take that constant outside and then apply the Laplace transform over the rest of the function. So by a linearity property, you can separate this 1 upon 2 from these functions, okay, and then take the Laplace transform of these functions and then apply the standard formula of sine at, Laplace transform sine at, which is equal to a upon p square plus a square, and here a is 1, so it is 1 upon p square plus 1. Okay, next one is sine square 80. Again, since we know the formulas of only single power of trigonometric function, but this is a second power of trigonometric function, so we have to use the formula of sine square 80. We replace this by 1 minus cos 280 divided by 2. So we separate this 1 upon 2 and cos 280 divided by 2 and then apply the Laplace transform. Similarly, sine cube 2t, you have to remove this cubic power by using the formula of sine 3t is equal to 3 sine t minus 4 sine cube t. So the value of sine cube t is 3 sine t minus sine 3t divided by 4. So we replace this t by 2t so that we have 3 sine cube 2t is equal to 3 sine 2t minus sine 6t divided by 4. When you replace t by 2t, it will be 6t. Now separate these two functions and then take the Laplace transform and apply the standard formulas as well. The last one is Laplace transform of 2 raised to the power t. Laplace transform of 2 raised to the power t is equal to Laplace transform of a raised to the power t. लेकिन हमने a raised to the power t का कोई स्टैंडर्ड फॉर्मूला नहीं पढ़ा है, तो हम इसको e raised to the power log e a लिख सकते हैं. a को, that is 2 को हम कांस्टेंट टर्म को हम एक्सपोनेंशियल पावर की फॉर्म में इस तरह से लिख सकते हैं. दिस इज इक्वल टू a. तो हम 2 को हम लिखेंगे e raised to the power log 2 raised to the power t. Okay, because this whole expression is equal to this expression. This whole expression is equal to this. So, and we know the formula for e raised power at Laplace transform. This t will come here, so that this will become e raised power a into t. A here is log 2 base e. So Laplace transform of e raised power at is 1 upon p minus a. So this is equal to 1 upon p minus a, which is log 2. This is a different question. So I hope you understand this lecture and the method of solving various type of problems using Laplace transform. So if you understand this video lecture, if you like this lecture, you can press the like button, and you can also share it, and you can also subscribe my channel. Thank you so much.